Good day everyone, this is our fifth laboratory experiment entitled Series Connected Resistances. The objective of this experiment is to verify the principles that govern resistances which are connected in series. The apparatus that we used was the FET simulator. In the diagram, we used tools in the FET simulator such as wire, battery, light bulb, resistor, switch, voltmeter, and ammeter. We place the tools in the center in which you can change the resistance of the resistor and the voltage of the battery.
On this laboratory experiment 5 called Series Connected Resistance, we first created a Zoom room for our meeting and one of our members shared their screen and opened the FET simulator called Circuit Construction Kit. We then proceeded filling out the table. The table consists of 3 trials. Trial 1 has a resistor 1 of 27 ohms and the resistor 2 is 10 ohms. It also has a current of 1.35 ampere which is constant. It has a voltage 1 which is 36.49 volts and voltage 2 is 13.51 volts. Trial 2 has a resistor 1 of 61 ohms and resistor 2 is 25 ohms. The circuit is also held constant at 0.58 ampere. Voltage 1 is 35.47 volts and voltage 2 is 14.53 volts. Trial 3 has a resistor 1 of 85 ohms. Resistor 2 is 82 ohms. The current is held constant at 0.36 ampere. Voltage 1 is 31.02 volts and voltage 2 is 18.98 volts. Brainstorming, observation, and conclusion out of this data, we are now ready to input it on the template.
For the table, in trial 1, the resistor 1 has a value of 27 ohms, while resistor 2 has a value of 10 ohms. For us to be able to compute the total resistor, we need to add the 2 resistors, which is 27 ohms and 10 ohms, which leads to the result of 37 ohms for the total resistance of trial 1. And the current throughout the circuit is 1.35, for it is a series circuit. And for its voltage, the first voltage is 36.49 volts and the second voltage is 13.51. And for us also to compute the total voltage, we need to add the 2 voltage, which leads to the result of 50 volts. Moving on, in the second trial, resistor 1 has a value of 61 ohms and resistor 2 has a value of 25 ohms with a total resistance of 86 ohms. And also again, for its current, for it is a series circuit, the current is the same throughout the circuit, which is 0.58 amperes for the second trial. And for its voltage, the first voltage is 35.47 volts and the second voltage is 14.53 volts with a total volts of 50. Lastly, for trial 3, the first resistor has a value of 85 ohms, the second resistor has a value of 52 ohms with a total resistance of 137 ohms, and its current throughout the circuit is 0.36 amperes, and for its first voltage is 31.02 volts, and the second voltage is 18.98 volts with a total voltage of 50 volts.
Series connected resistance is a type of resistance in which resistors are said to be connected in series when they are daisy chained together in a single line. This means that in a circuit, more than one resistor can be found in series. We are going to give the 3 resistors in the circuit the values we want in an increasing order for this lab experiment while keeping the battery voltage steady in all 3 trials. The battery voltage is 50 volts. On the first trial, we used resistors with values of 27 and 10 ohms. On the second trial, we used resistors with values of 61 and 25 ohms. And on the third trial, we used resistors with values of 85 and 52 ohms. We determine the value of each individual resistance using a voltmeter. We have 36.49 and 13.51 volts in a trial 1, we have 35.47 and 14.53 volts in trial 2, and 31.02 and 18.98 volts for the third trial.
It can be observed from the table that using the formula given, the total resistance of the series circuit is equal to the sum of the individual resistances. This can also observe with the voltage. The total voltage is equal to the sum of the individual voltage. Drops meanwhile the current is same all throughout the series circuit.
For our observations, in the series connected circuit, we have observed that as we close the circuit through a switch, the ammeters all read 1.35 amperes for the first trial, having the resistance 1 of 27 ohms and resistance 2 of 10 ohms, yielding voltage 1 of 36.49 volts and voltage 2 of 13.51 volts. Adding resistances 1 and 2, we can get the total resistance of the first trial, which is 37 ohms. Basing on the total resistances of each trial, as the resistance value increases, the current flowing in a circuit decreases, while the total voltage is held constant with the value of 50 volts. Referring to the values in current 1 and voltage 1, we can infer that voltage is directly proportional to the current, for when its value decreases, the current also decreases, while voltage is inversely proportional to the resistance shown in the table, for as the resistance increases, the value of the voltage decreases, and in that case, current is held constant. This just verifies the Ohm's law in a series connected circuit.
According to the data that we have gathered, the same current flows through each part of a series connected circuit, and if voltage is held constant and the resistance value is increasing, therefore, the current flowing through a circuit is decreasing, for resistance is inversely proportional to the current. And for instance, if the resistance is held constant, the voltage is directly proportional to the current, or as the voltage increases, the current also increases. One open wire in a series circuit could affect the whole circuit, for it means that no current can flow.